Okay, we'll look at an example on how to find the time in a compound interest account when the rest of the variables are given. So let's look at this question. Determine the time taken to earn 18,500. Now that's our final amount on a 5,000 investment. That's our principal. If it compounds yearly, so that means just K is equal to 1 at 1.7%, and that's our rate. Okay, so if we list all of that down, let's write that down. A is equal to 18,500. Our principal is 5,000. And K is equal to 1. We'll just write that down, done. And our rate is 1.7%, which is equal to 0.017 in decimal. Now, looking at the compound interest formula, A equals P brackets 1 plus your rate divided by how many times it's been compounded to the power of time multiplied by the compounding rate, which gives us, so all we do is we just substitute that. So our final amount was 18,500 and our principal is 5,000 multiplied by 1 plus, because K is equal to 1, so your rate is just 1 plus 0.017 to the power, again, your K is 1, and you have to find what the time is. Okay, I'm just going to write down, that's what you have to evaluate. Okay, so that gives us 5,000 times 1.017 to the power of T, and that's equal to 18,500. So we work backwards to solve for T. So therefore, the first step that we would do, if you read that, 1.017 to the power of T multiplied by 5,000 gives us 18,500. So we go in the reverse order, reverse opposite order, get rid of the 5,000. Therefore, we divide by 5,000 first on both sides. And if we do 18,500 divide by 5,000 gives us, so this gives us 3.7, and that is equal to 1.017 to the power of T. Now, as we've learned, okay, when you have the unknown in the power, if you have unknown in the power, the opposite of that is the opposite of the index rules or indices rules. The indices function is logarithm. So what we do is we take logarithm on both sides, and that gives us log of 3.7 is equal to log of 1.017 to the power of T. And when you have your power over there and you're taking the log, what happens is the power comes as the coefficient of the whole log function, which becomes T times logarithm of 1.017. And on the left hand side we have log of 3.7. Now, just as we've been doing to solve for T, it's been multiplied by log of 1.017. So on both sides we divide by log of 1.017 and do the same on this side, 1.017. So therefore, the value that we get for T is logarithm of, just rewrite that, log of 3.7 over log of 1.017. And if we evaluate that, we get that gives us approximately, so that's 77.6 years. Obviously time is in years, okay, which is, as a whole number of years, that's approximately 78 years.